Okay, so here's our first problem. Solve for the values of x and y in the given figure. Yesterday we learned that the interior angle of a triangle plus the interior angle of a triangle equals the exterior angle of the triangle. Inside plus inside equals outside, as long as they're not next to each other, which in this case, the 60 that I'm given is not next to the 120. So here are the two angles I'm using. I'm using the 60 and the x as my two inside angles, and I'm setting that equal to my outside angle. You can see my work down here. So x plus 60 equals 120, and then I go solve and I get x is 60. Anybody have questions on getting that x is 60? All right, then we also learned yesterday that the three inside angles of a triangle equal 180. So if I have two of the three, if two of them are 60, then I can figure out the third one. So I did 60 plus y, which is that third angle, to find that y is 60 as well. So x is 60 and y is 60 here. They're not always equal. They're equal for this problem. Anybody have questions on that one? All right, for the next one, I did the same thing. Inside angle plus inside angle equals that next to outside angle. I wasn't given the actual number for that second inside angle, but that is a 90-degree box, so I can assume that it is 90 degrees. So I did x plus 90 equals 135. X equals 45, so I just kind of filtered that in up there. And now I have two of the three. I have 45 and 90, so I can figure out the third because those three angles need to add up to 180. So x is 45 and y is 45. Anybody have questions on those two? Inside plus inside equals outside. Inside plus inside equals 180. All right, the measures of the three angles of a triangle are listed in each example below. Solve for x and find the measure of each angle. These are the three angles of a triangle. The three angles of a triangle add up to 180. So I'm going to take each equation and I'm going to add them together to set them equal to 180. When I combined like terms, I got 3x and 15. And I just worked my way through the problem to get x is 55. But it also says solve for x and find the measure of each angle. So I had to take that 55 and plug it into each angle as well to get the three different angles. So the three different angles were 65, 35, and 80. Any ideas on how I could check my work for those three? What needs to be true about those three angles? They have to equal 180. So if I add them up and I don't get them equal to 180, then maybe my x value was wrong. Maybe I did something wrong somewhere. All right, same idea for the next one. I'm going to take those three equations and add them together and set them equal to 180. Work my way through the picture. X is 3. But then I need to plug that in to get the three remaining angles. So plugging that 3 in, I got 70, 88, and 22. What do we think? Okay with that? Now this next picture is a little confusing. All right, there's a lot happening. So let's figure out, like, where can we start? I definitely see a triangle here. Yes. And I have the two of the three inside angles of the triangle. Did anyone use triangle sum theory to get angle A? What'd you get?
I got 62 degrees.
All right, so let's see. We've got so we're gonna do for this A, we're gonna do 38 plus 84 plus A equals 180. 112. I don't know that I'm gonna get 62 for this. Can you just double check that?
It's 58. I don't
Alright.
think we got the wrong one.
Okay. So if I add these together, I'm getting 122 plus A equals 180. All right, so because that's a triangle, I know the three inside angles of a triangle equal 58 degrees. So that takes care of the first angle. All right, so next it says angle B. Where even is angle B? Oh, here. We know that two inside angles of a triangle equal an outside angle. Would you agree with me that angle B is an outside angle? So we could look at it that way, or let's think about our pizza. Right, if this were a pizza, what's the relationship between this angle and angle B? Yellow plus green equals what? They're a linear pair, right? So yellow plus green equals 180. Do you guys see that when I'm making that? Okay, so then angle B must have a relationship of 180 minus 38, right? Because together they have to equal 180 degrees. $142. So angle B is 142. Let's kind of stick with our pizza down here. Can you get anything else from knowing that this is 142 or that yellow is 38? Do you see any other relationships there?
There's two vertical.
There's vertical angles, right? So which angle is vertical to angle 38? C. So if this is 38, then we know vertical angles are equal, right? So wouldn't C have to be 38 as well? Because they're vertical, so this is 38. All right, and then if this one's 142, then wouldn't this one have to be 142 as well because they're vertical and vertical angles are equal? So that gets me here, right? Anybody have questions on that part? All right, so let's make a new pizza. See if we can get anything from that. Let's look here. I've got this 84, right? That's given to me. And I've got this 55. That's given to me. I think I could probably do something to get F here. Any ideas of what the relationship between those three angles are?
Add 84 and 55 and then subtract 1 from 80.
That's a half circle, right? Do we agree? So I know that those three angles should add together to equal 180. So 84 plus 55 plus F equals 180. Okay, so that gives me F. Can I get anything from F being 41? How come? Very good. So they're vertical, or you could use that 180 relationship. So, okay, so E is 41. All right. Any ideas on G? There are a few different ways you can attack G.
You can add 84 and 55.
Though these two angles together are vertical to this one, so you could do that. Or would you agree that 41 and G are the bottom half of the circle? So I could also subtract 180. So however you want to look at that, right? We could do a bunch of different things. I need a different color. go with this like round color here. All right, so for this G, I'm gonna do 180 minus 41, or you could add those two together. There's a lot happening here. We're using a lot of relationships. Does anybody have questions so far as you see us kind of go through this? All right, let's see. We've got H and we've got J. Would you agree that J is an outside angle? Okay, so if I wanted to find J, I could probably use that outside angle relationship. So to find J, I can do inside angle, which is 41, plus inside angle, which is 72, to equal my outside angle. Oh, that's J. All right, and what about H, our last one? Any ideas on how I can find H? The very last angle on here.
113 minus, I meant 180 minus 113.
180 minus 113. Or, can anybody see another way to do that one? They are a linear pair, I agree. You could subtract from 180. Anything else you could do to find H? H is inside of a what?
Triangle.
And we have two of the three angles. Okay, so you could do 41 plus 72 plus H equals 180, which essentially gets you exactly what Gabe just said. We're going to subtract that 113 from here. Of course, there's a 6, 7. All right, so that was hard. Anybody get all of them? That's a really hard problem, especially never seeing anything like that. So hopefully now it makes sense. You see a lot of relationships. This is like a really good practice. We saw, I think, everything on here except a complementary pair, right? So like looking at the backboard, we did a linear pair over here. We did vertical over here. We did triangle sum here and here. We did exterior angles here. This is everything we've done so far except complementary. There was no 90-degree boxes. All right. Okay, so for today, I can identify a transversal. That's a new word. I can identify corresponding same side interior, alternate interior, same side exterior, and alternate exterior angles. Those are new words. New vocab. Sorry. Okay. All right, so you are going to need your toolkit and your workbook, so you can keep that out. We are here. I'm going to look over Carissa here to see what page we're on here. All right, so page 7 of your toolkit, it says a transversal is blank. A line that intersects two or more lines at a distinct point. Okay, so what you are writing is the first sentence. I think the second sentence is already on there for you. So a transversal is a line that intersects two or more lines at a point. So in order to be a transversal, this particular line has to hit two other lines. Okay, if it only hits one line, it's not a transversal. So on this picture, I need to find the line that's hitting two other lines. And it has to hit like on the paper. These two lines would eventually intersect if I extended them, but I'm not seeing that right now, so I can't consider those transversals. So my transversal is this line, because as I trace over this line, I hit one line there and I hit another line there. So this is the line that's intersecting two lines. This line here hits this line, but it doesn't quite meet the other line, right? That only intersects one line. And this line here intersects orange, but it doesn't quite meet pink yet. So the only line that's intersecting two lines here is is the orange line, which we'll call line T. That's what that letter is there. So on the picture below, line T is the transversal because it intersects both line L and line S. A transversal, think T, 2. Transversal has to hit 2 lines. It could hit 3, and it's a transversal. It just has to hit at least 2. All right, so this I don't believe is in your toolkit, but I just want you to think about it. If I gave you this picture, would you be able to identify the transversal? So think about what that definition is. A line that intersects 2 or more lines.
No.
Which one's the transversal? This one is the transversal, all right? All of the definitions that we do today is based on the word transversal. So like all of the definitions have that word in it. So I just need you to make sure you understand what it means so you can understand what the other words mean, okay? I think you'll find that these vocabulary words are kind of easy. A lot of the actual words themselves have what they mean in their word, right? Like the definition is kind of in the word. So the first word on your toolkit is corresponding. So on the far left column, it says corresponding. And then in the middle, it says definition. So the definition of corresponding angles is in red on the board. It says lie on the same side of the transversal in corresponding, meaning similar positions. Out of all of the words you're going to see today, I think this one's the hardest one. I think the other ones are fairly simple. So corresponding angles lie on the same side of the transversal, so there's that word, and in corresponding positions. Okay, so we already talked about how T is the transversal, right? T is the one that's intersecting the 2 lines. So sometimes the transversal is almost vertical, and sometimes the transversal is horizontal. So when it's saying land on the same side of the transversal, it depends on which way your transversal looks. I would call this more of an up and down line. So when your line is up and down, your 2 sides are your left and your right. Whereas if it's side to side, your 2 sides are up and down, okay? So for this transversal, to lie on the same side of the transversal means your angles are on the left or they're on the right. Make sense so far? All right, so if I'm looking for angles on the same side of the transversal, angles 1, 4, 5, and 8 are left side angles. And angles 2, 3, 6, and 7 are right side angles. So that's the first part of the definition. It says they have to lie on the same side of the transversal. So when I pick a pair of corresponding angles, they're going to either both have to be blue or they're both going to have to be red. That's the first part. The second part says they lie in corresponding similar positions. So here's what I mean by that. We've got this line and this line. If I were to describe angle 1 to you, I would say it's on the left of the transversal and above the orange line. Do you agree? Left of the transversal, above the orange line. So the corresponding angle to that is another angle that's to the left of the transversal and above the orange line. So I'm going to take from here and go down here. And I'm going to figure out, well, which of these angles down here is to the left and above. You see that that would be angle 5. So angle 1, so where it says, I think it says examples on the right-hand column. Angle 1 and angle 5 are corresponding angles. These are my left above angles. angle 4 and angle 8 are also corresponding because they are on the left side of the transversal, but each of those are under their line, right? If I'm looking at the orange line, 4 is below it and 8 is below it. So these are my left and below angles. I also have corresponding angles on the other side. Anybody think they can do a pair on that side? What do you think? 2 and 6. 2 and 6 are corresponding. These are right side angles that are above the line. And then 3 and 7. These are right side angles that are below the line. So similar positions means the description of them is the same. All right, corresponding angles. These are all of the pairs from this picture. Same side interior angles are exactly what they sound like. They are on the same side of the transversal, same side. Interior means inside, okay? So the definition is the word. Angles on the inside that lie on the same side of the transversal. You might not even need to write the definition down, right? Because it really is the same thing as the word. So remember what our transversal is. That's our transversal. And remember we had our left angles and our right angles. Right, these are on the right of the transversal. These are on the left. So in order to be same side interior, they need to be on the same side. So I'm looking at either a pair of blue or a pair of red. I'm not mixing and matching the colors, right? That's the same side part. They're on the left or they're on the right, okay? Interior means they're on the inside. So when I think of my two lines being horizontal like this, I think of like a hamburger, right? So think of like these two lines are the bun. Your inside is the meat because it's on the inside of the burger. Your outside is the bun. So my inside angles are these ones in here. It says interior, right? So this is my interior angles. So they need to be on the same side and on the inside. So what are my pairs?
4 and 5.
4 and 5. 3 and 6. So in your example part, you would write 4 and 5, 3 and 6. The left hand interior versus the right hand interior. There are two pairs of those. Alternate interior angles are exactly what they sound like. Alternate means they're not on the same side of the transversal. In this case, I'm going to pick one blue and one red. They're on different sides. They lie on different sides of the transversal and interior the inside. Now there's one extra piece to this definition that you might want to add in, and it's that they are non-adjacent. What does that mean? Non-adjacent, not adjacent.
Not next to each
They
other.
can't be next to each other, okay? So that piece isn't necessarily in the word. All right, so if this is my transversal, these are my interiors. We talked about inside. And these are my left. And these are my right. I want to take one left angle and I want to pair it with one right angle, but they can't be next to each other. That's that one piece. So I can't pick 4 and 3 because they're next to each other. So 4 would only be able to pair with 6, because 4's on the left, I need an angle from the right, but it can't be next to it, so it can't be 3. So that would mean 5 couldn't pair with 6 because they're next to each other, but I need an interior left angle, so it would be 5 and 3. Are we okay with that? alternate interior. All right, and then we're gonna do the same exact thing, except we're gonna change the word interior to exterior. So instead of looking at the inside angles that are kind of like an inside angle's like pushed in, they're forced in, they're blocked in by two lines. Exterior angles are not blocked in, they're on the outside. So my exterior angles in this picture are these ones, right? They're not blocked in by anything. And remember, we've got our left angles and we've got our right angles, and those are based on that transversal being what's separating them. The transversal's not always up and down. Sometimes it might be side to side, which is going to make the picture look a little different. So if we're looking for same side exterior angles, same side would mean that I need them both to be blue, both on the left, or both to be red, both on the right. So there's really only one pairing option here. It's got to be 1 and 8. And it's got to be 2 and 7. You okay with that? Last one, same definition. We're just changing the word interior to exterior. The definition itself is the same. I'm just looking at a different part of the picture. Remember, the only tricky part to this definition is the fact that they are non-adjacent. They can't be next to each other. Angles that are on the outside, so that's what I'm circling in black, they can't be next to each other. So it can't be 1 and 2, and it can't be 8 and 7, because those are next to each other. And they're on different sides of the transversal. So I'm looking at 1 and 7 and 8 and 2. Eventually next week, we'll learn not only do these relationships have a name, but they have a number that goes with them. Like there is a angle 1 plus angle 2 equals 90, an angle 1 plus angle 2 equals 180, or an angle 1 equals angle 2. One of those three relationships we've been talking about will apply to all of these. Okay, so we'll put that on there. But I just want to make sure, at least today, you're good with the actual words before we put numbers to them. So we're going to practice the vocabulary. So just a quick check-in, seeing if you know how to do this vocabulary applied to a different picture, right? So the transversal is going to look different. This is on Socratic. We did one of these yesterday, so you should know how to get there. Now, numbers 7 and 8 are difficult. They're not like the ones we just did. My recommendation to you would be to draw the diagram on your picture and see if you can focus in on only the lines that are necessary. These pictures are going to have like 5 to 6 lines on them, but you only need 3 of them. So try and figure out which 3 are relevant and draw the picture without the other ones. It might help, okay? If you get these wrong, it's okay, but it's a challenge, and I think sometimes challenging ourselves is good, so give it a shot. All right, this is great. What I needed you to know was 1 through 6, and you can see by the results here, you definitely know that. I'm just going to quick show you like what I would do to get this answer here. So it only takes 3 lines to make your 2 angles, but there are a lot more than 3 lines on this picture. So what I do is I draw the whole diagram out if it's not on my paper already, and then I trace over the lines that make Y and the lines that make X, right? So that's what that looks like. And then I redraw the picture with only those things. So here's Y. Here's X. And it becomes a lot more clear what that relationship is without that all that other white noise around it, right? So now seeing it, they're on different sides of the transversal, the left and the right, and they're on the outside, which is what's making them alternate exterior angles. All right, same idea with the next one. There is a lot more to this picture than what I need. So I could trace over what makes X. So that's like and X is here. And then what makes Y is this line down here, and Y is here. Well, X is an interior angle and Y is an exterior angle. So process of elimination means it can't be anything with the word interior or exterior, right? Because it's one of each. Well, that only leaves me with one option. It's corresponding. X is a right-hand angle and it's below the line. Y is a right-hand angle and it's below the line. They're in the same position. So that's why that one's corresponding. We're actually going to do something pretty similar to this type of problem right now. So in your workbook on page 26 is a problem like this. I want to do one with you. And then we're going to end class with, you're going to be able to pick a partner if you want, and you're going to try some of these more challenging ones. And then I'm going to have some of you maybe post your answers around the room so that we don't have to go over them on the front board. I don't know if we'll have time. Maybe we'll have time to do one more. All right, so on page 26, which I still am never confident about my page numbers. This is right, okay. On page 26, it says, what angle relationship, if any, can you identify if line A is the transversal for lines D and E? Hint, it may help to redraw the diagrams with just lines A, D, and E. So, if I had this diagram, here's line A, here's line D, and here's line E. So I'm going to redraw that. And I'm only going to draw what comes of those angles. So if this is A, this is D, this is E. So up there in the top left-hand corner, there's an 8 and a 7. I'm not going to write anything on the top left-hand side is the 8 and 7. The top right-hand side, I'm not going to write anything of that because I would need lines B and C for angles 3, 4, and 6. Do you guys see that? They're kind of out there. If I were to write 3, 4, and 6, it would look like this. I wouldn't know what's what. Okay, so those angles are irrelevant with these specific angles that I'm given. Oh, man. All right. And then I'm going to look down to see what E gives me. So it looks like E gives me 1 and 2, but I would do this. And then I wouldn't know what's 1 and 2, right? In order to write 1 and 2, I need that diagonal line, and I don't have that. So E's not giving me anything either. So based on these specific 3 lines, the only pair of numbers I can really look at is 8 and 7. What's their relationship? Well, I like that you said that because I understand where you're coming from. 8 is exterior, yes? 7 is interior, so it can't be anything interior or exterior. The reason it's not corresponding, if I were to describe 8, I would say it's on the left-hand side of the transversal and above the line. If I were to describe 7, I'd say it's on the right of the transversal and below the line. To be corresponding, they both need to be left and above, or right and below, and they're not. So this is not any of the relationships we talked about today, but you do know what they're called. Vertical. Angle 8 and angle 7 are vertical angles. So I want you to see if you and a partner are able to kind of depict these pictures and this given information and figure out which relationships, if any, there are. For some of them, you're going to write there aren't any relationships because it does say if any. Now that we've done one, I'm thinking you should be able to try to do the other ones. So originally, I had that I was going to give you a random partner. I was going to do a random partner generator, but I'm not. It's Friday. I'm going to let you pick who you will work with. Okay? If you want to work alone, you can. If you want to work with someone, you can. All right, so what I'm looking for you to do is page 26 and 27. Just like we did here. See if you can figure out which relationships, if any, you get from the given information. So 26 and 27, all right? I'm hoping to go over the answers before we leave today. So we've got a little less than 20 minutes. You guys know what you're doing? All right, you can move around, work with someone, work on your own. You're doing page 26 and 27 as your practice.